Okay, Nancy. Um, Please explain your 1949 paper, the Ursa Major Group, in the Astrophysical Journal that's based on your doctoral dissertation work, particularly the moving cluster method and how you found what was really going on.
Well, I didn't discover the moving cluster method, but it is a way of finding out how far away stars are. We assume that all the stars in a cluster were born more or less at the same time in pretty much the same general space. So if you find stars that are scattered all over the sky and get their velocities and trace their velocities back, in other words, just reverse direction, they should all end up in the same place at the same time. And so what you do, is to get the velocities of the stars. Well, you can find the velocity of the stars toward and away from you very easily, but finding the velocity of the stars in the other two directions is a little harder. But what you can do is you can see their motion on the sky, and the amount of that motion is a function, of course, of their velocity, but it's also a function of their distance. So if you calculate the velocity that is necessary to get the star back to the center of the cluster at the right time, you know how far away the star is.
And what did you find out about the Ursa Major group that people thought was just one cluster or one group of stars?
Well, I don't think I found anything new about the group. What I did find out was how bright many of the members that were scattered all over the sky were, and this helped us to figure out and essentially calibrate how bright stars that look similar to them would be, how absolutely bright, how bright they would be if we put them at a standard distance.
But tell us about the fact that you were able to separate them into two different groups depending upon their velocities.
Well, that was not the Ursa Major cluster. That was the work that I mentioned already, the finding that stars with different compositions behave differently.
So you already realized that before the Ursa Major work?
No, that was
afterwards.
That was several years after.
What, 1950, 1951?
Probably closer to 52 or 3, but I'm not sure exactly.
Okay.
Maybe 52.
Okay, please explain the discovery of a thick disk in the Milky Way galaxy.
Well, I wasn't involved with the thick disk particularly, but as I said earlier, what I found was that the stars with less hydrogen stayed closer to the Milky Way, and that was the group that was later classified as the thick disk.
So that was after 1949. That would have been in the early 50s.
Quite a bit after.
Okay. So, how do you understand the structure of our galaxy based upon your work and the work of others that later built on your work? Where they talk all the time about Nancy Grace Roman's thick disk in our galaxy.
Well, I never called it a thick disk. So.
You don't, but that's what they call it. And they do associate your name with it in their publications.
I see. I guess I hadn't realized that. Well, as I say, I found that stars with less hydrogen stayed closer to the Milky Way plane. They moved around the center and closer to circular orbits, whereas stars with more hydrogen scattered farther from the Milky Way plane by a significant amount. It had been known for several years, thanks to work by Oort in the Netherlands, that stars with very few metals, very strong, very much hydrogen, very much more hydrogen compared to the heavier elements, moved quite far from the Milky Way plane and moved around in very elliptical orbits. but nobody had ever had any idea that the normal stars, stars that we've grown up with, also showed those characteristics, but to a much less degree.
Okay. I also noticed when I looked at your resume on the Montgomery College site that in 1980 you took a Fortran course at the local community college. Of course, this was a long time after you got a PhD
Yes,
in
well,
astronomy. Why did you do that? Why did you go back and take a Fortran course at a community college?
well, I had learned something about computers and computer programming back in 1956, when it was quite a different field from what it is now. But I realized that after 20 years in administration, that that computers had changed and changed very drastically. I realized that if I was going to do astronomy research, I had to learn two things: modern computers and digital photography. Well, I never did learn how to handle digital photography. I've used it, but I didn't do the actual measurements and reduction of the data myself. But I did, so the first thing I did was to decide that, as I say, that I needed to learn something about modern computers. And it was convenient to go to Montgomery College, and as a senior and a retiree, I could edit a course without paying tuition, so it was very inviting.
What type of research did you end up doing with your Fortran knowledge?
Well, a major job that I had for 17 or 18 years was archiving machine-readable versions of astronomical catalogs. So this meant checking them for errors and essentially showing how to use them.
So we wouldn't even have these catalogs if you hadn't learned Fortran, right, from the local community
I
college?
guess probably to some extent that's true. There were other people doing it, both in this country and particularly in the Netherlands and some in Russia, but at least some of the work would not have been done if I hadn't learned Fortran at the community college.
Thank you very much. Would you like to say anything more about the Ursa Major cluster, the thick disk, or anything like this? I've never had a very good class on Milky Way galaxy dynamics. What would you teach me? First, how would you organize a class, because I'm getting ready to teach a class in Astronomy 202, and if I wanted to teach my students about the evolution of the Milky Way galaxy, how would you break it apart? Well, how would you, what would you make as the major themes to teach my students?
I think I probably would start out by the question of how different types of stars were not completely evenly distributed in the galaxy. I also talk about the fact that there are a lot of very old stars in the center of the galaxy. I also talk about the spiral arms, the fact that the spiral arms are particularly noted for their young stars. And I talk about the formation of stars from interstellar clouds. And
that part, at least, I'm familiar with, since I wrote a doctoral dissertation on 3-year linear hydrodynamics of star-forming regions. But the other parts, I'm not so sure about. But you're the person that discovered a great deal of that.
Well, I discovered some of it, but there's
Not
been a
all
lot.
of it, but you got a lot of.
There was
yes.
some that was discovered before I was
Right.
involved.
And quite a bit afterward,
And
too.
quite a bit afterwards, yes.
Thank you. You've been very helpful in the syllabus I will write soon.